Welcome to 7.2 Transformations of Exponential Functions. So in our last lesson, we kept things fairly simple and we only did things in this form. Y is equal to some constant to the power of x. Well, now we've really brought the full power of our previous unit about transformations, and we're using all these different types of transformations for exponential functions. So this c is still the same c. Now that's a constant, okay? So just looking at our examples for a second, here the c value is 2, here the c value is 3. It's not -3, it's 3 because the -3 is not in parentheses. Looking at the bottom here, the c value is 4 and there the c value is 3. So that's how I identify the c values. And then the a and the b and the h and the k really mean the same things as they always have. So what does the a mean? The a is your vertical stretch. Okay, so the y values get multiplied by a. B is your horizontal stretch, or I can't spell, horizontal. We'll try that again. How about we'll just go hor for that. Is your horizontal stretch or compression, and the x values get multiplied by 1 over b. Okay, so they get either, you could think of it as being divided by b or being multiplied by the reciprocal of b. Okay, now these are the two transformations. You want to do these first. Okay, it doesn't matter which order you do them, but you want to do the vertical stretches or compressions first. What you want to do second then is your h, and h is a horizontal shift. In other words, left or right. And k is your vertical shift. And just a reminder about the h, it is in the form of minus h. Okay, so over in this one over here, your h would be equal to -1, so it would be left 1. So this is the way to think of it here, is that's because it's +1 and we want it in the form of minus, so minus 1. Okay, so let's take a look here at how this works in Desmos for a second here. Our first one is 2x plus 1. So this might look a little bit complicated, but I've put in my y is equal to, I put in this whole formula, and for our first example it is 2. So looking back, this is 2 to the power of x plus 1, so my c value should be 2, and my a should be 1, my b should be 1, my h should be 0, and my k should be 1. So right now I have things, so it's just showing y is equal to 2 to the power of x. And you'll notice those 2 points that we mentioned last lesson. 0, 1 is going to be common all the time, and then 1, whatever the c value is. In this case, because it's 2 to the power of x, it's 1, 2. Now, what we need to do here is add a k value of 1. So if I go to k, and if I add k and make 1, you'll see how it shifts upwards. So my purple line is my original, as what I can call my parent function, and now this is the image, this is the new one. Okay, so we don't have Desmos to help us along the way, but I think a good strategy is to first, if you're doing this with pencil, so lightly do the parent function. So my parent function is equal to y is equal to 2 to the power of x. And you'll get 2 points from that. You'll get that 0, 1, which is always common, and then 1, 2. And so this is in my original function, so it looks like this, and it goes up. And we can even add the next one. If we go put a 2 in there, 2 squared, that'd be equal to 4, and we'd be going up like that. So that's my parent function. Not a great curve. And now you're going to say, oh, but now I need to make one change. I need to go up 1. So now I'm going to say y is equal to 2 to the power of x plus 1. So I can take these 2 dots that I wrote and I can just shift up 1 for each of them. And so the other thing to watch out for is we had a horizontal asymptote at y is equal to 0. So now because we're going up 1, we're going to have a horizontal asymptote at y is equal to plus 1. So at this point, what I would do is use my eraser and erase my original parent function, and then, I guess I'm doing it in blue here, draw my new function. So I'm going to be going up like so. Okay, and I can draw the horizontal asymptote at y is equal to 1. Okay, so that's the easiest strategy. Start with the parent function of one that you knew from the previous lesson and just say, let's go up one from it. Okay, let's go down. Oh, I guess we should do the one on the right if we're going to do them in order of difficulty. This is y is equal to minus 3. I'll zoom it in a bit more so I have a bit more space. Y is equal to minus 3 x plus 1. So in terms of my transformations, my a value is going to be equal to negative 1. If I had another number in here besides this negative sign, it would be something besides 1. So I know that that is going to be multiplying all my y values by negative 1, so it's going to have a reflection over the x-axis. So when I'm looking at that, I'm thinking instead of having this kind of shape, once it gets reflected, it's going to have this kind of shape. All right, and this plus 1 here, we have an h, which is equal to negative 1. So let's do the same as before. Let's start with the parent function, and the parent function is y is equal to 3 to the power of x. And right away I know, okay, my first point is 0, 1, and then 1, 3, and I've got this kind of a sketch. I'm really not doing a great job of hitting the dots, but I know I'm going to be erasing it right away. Now I've got two transformations to make. I do my a and my b first, so I'll do my a first. So I need to reflect over the x-axis. So here I'll do my image in green, so I can put 1 here. And then this one, instead of 1, 3, it's going to be 1, negative 3. And I'll even do this as a quick sketch here. So far, this is what we have. This is my original y is equal to 3 to the power of x. And now my green one here, this one is y is equal to negative 3 to the power of x. But now I need to put the plus 1. In other words, if h is equal to negative 1, I need to go left 1. Let's pick red for this one. So if I'm going left 1, this point will be over here. This point will be over here, and everything else kind of moves over a little bit. So it goes not a great line, but it is really hard to sketch with this thing. Okay, so that's my final answer. This would be y is equal to negative 3 to the power of x plus 1. And then I would be getting my eraser. I'm going to leave these out here just in case you want to see it. I guess you can pause, so I'll erase it. So at this point, you would erase your other drawings on here, and you got your final one. You might want to do the little sketches on the side just to think about what you're working on. Let's go see how nicely Desmos will do this one. So it's minus 3. Okay, so my a value should turn into a negative 1. And what else did I have? I had a b value of 1, and h of minus 1, and my k was 0. Okay, so this is how it looks pretty good, isn't it? So I go through negative 1, negative 1, and then 0, 2, negative 1, negative 1. Oh, I've got 0, 3. Did I do an error here? Oh, I know what I did wrong. So if I go back to Desmos, my c is not 2, it's 3 to the power of x, not 2 to the power of x. There you go. So that's what my graph looks like. All right, so let's go take a look at this 4 to the power of minus x plus 1. So my original parent function, I'll start sort of in my margin. I'll say if my parent function is y is equal to 4 to the power of x, then I know it's going to be going like this. And I will have 2 points. I'll have this 0, 1, and I will also have a 1, 4. The next thing I'm going to apply is this negative value here. So that negative value means that my b is equal to -1, which means that all my x values get multiplied by -1. Or another way to think of it, and maybe I'll switch to green here, another way to think of it is that I get a reflection over my y-axis. So when I draw it at this point, now I'll say, okay, this reflected over the y-axis is going to have this kind of a shape, right? And I can say over here, well, this is my x and this is my y. I need to multiply all my x values by -1. So now I'll get 0, 1. This multiplied by -1 is still 0. And then this multiplied by -1, I'll have -1, 4. So this is my 0, 1. And then I'll have over here somewhere a -1, 4. And then my last step is this -1, maybe red. So my last step to say that k is equal to -1 means I go down 1. So all my y values have 1 subtracted. So looking at this one, my x stays the same, but my y goes down by 1, so it's 0, 0. And on my second point, -1, 4, it's going to be -1, 3. And again, looking at my graph, it's this one here, except for now it'll be coming down and going like this. This one had a horizontal asymptote at y is equal to 0. Now because it dropped down 1, it'll have a horizontal asymptote at y is equal to -1. So I'll draw that. I'll try to do a good job here. I'll draw that horizontal asymptote at -1. And then the 2 points that I figured out were at 0, 0, and then at -1, 3. And so here would be my sketch. Arrow there and arrow there. All right. Let's go see what that looks like. So my C value is 4. My C value is 4. My A value is equal to +1. My B value is equal to -1. And my H is equal to 0. And my K is equal to -1. Okay, so I have my original is my, in purple, is my y is equal to 4 to the power of x, and then after all those transformations, this is what I get, and I get my -1, 3, and my 0, 0. You can see how those 2 points get played out. Okay, kind of cool. All right, for my last one here, y is equal to 3 to the power of 1/2 x. My parent function in here would be y is equal to 3 to the power of x, which would look like this. And the 2 points that I knew, I'll even draw it on here, the 2 points that I would know from that one would be 0, 1. And the second point would be 1, 3. Now, what's the half in this case? This half is going to be equal to the b. b is equal to 1/2. How does b work? b multiplies my x values by the reciprocal of a half. So I'm going to be multiplying the x's times 2. All right, so my x values, these are these ones over here. So horizontally, it's going to get stretched. So instead of being 1 away here, I'll pick a new color. Instead of being 1 away, this is going to be 2 away. All right, or looking at this, instead of 0, 1, my x value gets multiplied by 2, so I still have 0, 1, because 0 times 2 is still equal to 0. My other one was 1, 3, and that gets turned into, so I'm going to multiply this times 2, and I'll have 2, 3. And that's what happened to, oh, sorry, I put it in the wrong spot. That's what happened over here, is that this gets multiplied by 2. So this one stays the same. That one gets moved out. All right, so my new function looks like Oh, I'm doing a really bad curve here. Pretty bad curve. Okay, so it looks a bit like this. There's no vertical shift, so we just have this coming out this way. Okay, so let's try to do this in Desmos where C value is 3. So I bring this down to 3. My A is 1. My B value was equal to a half. There we go. Oh, not a negative half, but a positive half. And my K is 0. Okay, so let's take a look. Let's see how this works when I do my B value. So if I do back to 1, and if I change it to half, see how it stretches horizontally. It gets farther out. Okay. If I make my B value 2, it's going to horizontal compression, and so you can see that orange line come inside. Okay. And the other thing about the B value being between 0 and 1 of that having that horizontal stretch is that you can see that the stretch means that the new line is further to the right of the parent function when x is positive, but when x is negative, because it's getting stretched horizontally, stretched to the left here, that's why this orange line's on the top. And you don't really have to worry about being that meticulous, but you can kind of see how the line crosses over at 0, 1. All right, we've got one super duper question to do here now, putting a lot of stuff together. And I just want to introduce or remind you, I guess, is some of the stuff that we did in transformations when we had a whole bunch of transformations. We said if we had a original point, I'm trying to spell the word original, and we put it in the form of an ordered pair, x, y, then we could also figure out the image, the new point, of each of the points. And remember what we did. The x values get multiplied by the reciprocal of b, or get divided by b, and that happens first, and then plus h. Okay, something that we did before. The y values get multiplied by a, and then we say plus k. So if we know any points, an ordered pair of any points on the original graph, then we can make the x divided by b plus h and a times y plus k for our new one. So in this case, if our parent function would be y is equal to 3 to the power of x, that would be here, y is equal to 3, I'll try better, 3 to the power of x. And 2 points that we would know right away would be 0, 1 for our original graph, and then we would know 1, 3. So those would be 2 points. So we can apply these transformations to it. So let's figure out what is b, h, a, and k in this question. So my a value is going to be equal to 2 right here. My b value is going to be, there's nothing that's multiplying with this x, so my b is equal to 1. My h is going to be equal to 1. It's already in the -1 format. And then my k is going to be equal to -4. So maybe what I'll do is here, I got an idea. Oh, I was hoping to do this catch. No. Sorry guys. I was trying to copy and then just scroll it downwards. Oh, can't seem to get it done. So what I'd like to do is write out this again, this x over b plus h and such, with the b put in there. So this is going to be x divided by 1, because b is 1, plus my h, which is 1, comma, my a value is 2, so it'll be 2 times y, and then k is -4, so say -4. Okay, so this is the transformation I'm going to take. So what happens to my 0, 1? 0 is my x, so it's going to be 0, 1 plus 1, comma 2 times y, which is 1, minus 4. So my 0, 1 point is going to end up being 1, -2. So that's the first point I'll put there, is 1, -2. My second one, my 1, 3, is going to be, so I'm looking over here, 1 over 1 plus 1 will be my x value, and my y value will be 2 times 3 minus 4. So 1 plus 1 is 2, 6 minus 4 is 2, so my second point is 2 comma 2. Now all we have right now are 2 points. We have this 1 comma negative 2 and our 2 comma 2, so this isn't really a complete replacement for the kind of thinking that we were doing in our last on the previous page. We should still get a sense of, okay, what does y is equal to 3 to the power of x look like? It looks like this. Okay. Now let's think about our transformations. We should do our a and our b first. So a means that all my y values get multiplied by 2, and my x values just stay the same because b is equal to 1. So if I say, okay, now let's add my 2 in there, so y is equal to 2 times 3 to the x. So I'm adding that. I get a vertical stretch. So it's going to look a bit more like this. So it should still have a horizontal asymptote. So it looks a bit more like that. So instead of 0, 1, at this point it's going to be 0, 2, right? And instead of 1, 3, it should be 1, 6. Now my other transformation is the going down by 4. So now I should have 2 times 3 to the power of x minus 4. So here I have a horizontal asymptote along the x-axis. When I drop this down 4, and I'll go to my real graph, I should have this horizontal asymptote at y is equal to negative 4. And I should have this type of a shape. So you can see now that we have the horizontal asymptote and we just have a sense of what it's going to look like, we can put some things in here. You might say, hey, I wonder where it crosses the x-axis, because I know it's going to be very steep coming along here. So I know it's coming like this, and it's getting less steep. And I know that it's going to be approaching here. All right, but I'm curious, where exactly does it cross this x-axis? Well, what does it mean to cross the x-axis? It means that x is equal to 0. So really what I'm doing is I'm wondering, what's my y value when x is equal to 0? So completing this, 2 times 3 to the power of negative 1 minus 4. 3 to the power of negative 1. Now remember that is equal to 1/3. So this piece here, this is 2 times 1/3 minus 4. So this would be equal to, I'm going to just do some erasing here. Oh, try to do some erasing. This is going to be equal to 2/3 minus 4. So 2/3 minus 4, that's going to be the same thing as 3 1/3. So in other words, when x is equal to 0, y is going to be equal to 3 1/3. So where does that cross? Oh, should I have, oh, minus, pardon me, 2/3 minus 4, minus 3 1/3. So it should cross at minus 3 1/3, about right here. So now we can get a sense of where it crosses. And if we know that spot, here let's put 0, negative 3 1/3. Right there. And this part we know for sure is equal to 1, negative 2. And this part here is equal to 2, 2. Okay, so those are our points. It says write the equation of the asymptote, and the asymptote is going to be equal to y is equal to negative 4. A couple of notes on the bottom. It says that 2 is a constant and doubles all the y values. If f of x is equal to 3 of x is equal to the original function, this is a nice way to pick out the function notation, because you can really see the transformation values. and B would be equal to 1 because there's nothing showing over there. Okay, so here's your homework. Page 354, 1 to 4. 6, choose any two from number 6, choose any two from number 7, and then these two in the C section. Thank you.